Welcome back to MarkTechPost, the podcast where we dive deep into the fascinating intersection of artificial intelligence and machine learning. Today, we're exploring something really exciting: building an intelligent, conversational machine learning pipeline. Imagine making complex ML workflows more accessible and interactive, and we're doing it by integrating LangChain Agents with the power of XGBoost.
That sounds fantastic. Traditional ML pipelines can be quite daunting, right? Requiring intricate coding and a lot of manual orchestration. It often feels like you need to be a seasoned conductor just to get a simple melody. So, simplifying this process is a huge win.
Exactly. The complexity barrier is real. You need specialized skills and a deep understanding of various libraries, plus that meticulous manual effort for data prep, training, evaluation, and deployment. It's a significant hurdle for many. But what if we could introduce a more natural, human-like way to manage these complex workflows? That's where our solution comes in.
And that's where LangChain Agents and XGBoost shine, right? You're using the agents as the intelligent orchestrator, like a maestro, directing the components, and XGBoost as the powerhouse for the actual predictive analytics. It's like having a brilliant conductor leading an exceptionally talented orchestra.
Precisely. The agent provides the conversational intelligence and workflow management, while XGBoost delivers the raw predictive performance. To make this happen, we're relying on a suite of powerful libraries. For orchestration, we have LangChain, specifically LangChain, LangChain Community, and LangChain Core. For the ML muscle, it's XGBoost, and for data handling, the ubiquitous Pandas and NumPy. And for visualization, Matplotlib and Seaborn. A simple pip install gets you all set up.
That's a great toolkit. So, the ultimate goal here is to build and demonstrate an end-to-end ML pipeline that's not just automated, but also interactive and explainable, making the entire lifecycle feel less like coding and more like a dialogue. How do we actually start building this intelligent pipeline?
It all begins with data management. In this context, data is the bedrock. We need a way to handle data generation, preparation, and summarization that's easily controllable by our conversational agent. This is where the data manager class becomes crucial. Think of it as a dedicated assistant for all things data related, encapsulating these tasks and making them accessible through our conversational tools.
A dedicated data assistant sounds perfect. What are its primary functions? I'm guessing generating synthetic data is key for demonstration and testing, especially when real-world data is scarce or sensitive.
You got it. The generate_data function uses scikit-learn's make_classification to create artificial datasets. We can specify parameters like the number of samples and features, and even fine-tune complexity with n_informative and n_redundant features. After generation, we immediately use train_test_split to create our training and testing sets, ensuring robust evaluation on unseen data. It's a standard, crucial step.
And how does the LangChain agent interact with this data generation process? Does it need complex inputs, or is it straightforward?
It's beautifully simple for the agent. We expose generate_data as a LangChain tool with the description "no input needed." This means the agent doesn't need to figure out complex parameters, it just triggers the function. The data manager handles the rest, and the output is a clear confirmation message like dataset generated, 1000 train samples, 200 test samples. Clean and direct interaction.
That simplicity is key for conversational interfaces. But generating data is only half the battle, understanding it is vital. So, what about data summarization? Does the data manager handle that too?
Absolutely. The get_data_summary method provides exactly that. Before we even think about training a model, we need to know the dataset's characteristics. This method compiles key statistics into a structured JSON format, including the number of samples, features, and crucially, the class distribution for both training and testing sets. This class balance information is critical for choosing the right metrics and understanding potential biases.
So, a user could ask the agent to generate data and then immediately get a summary? That sounds incredibly efficient for initial data exploration.
Exactly. This summarization capability is also a LangChain tool. If a user asks, "Can you generate a new dataset and tell me its summary?" the agent intelligently sequences the generate data tool followed by the data summary tool. The user gets immediate, actionable insights without writing any specific data analysis code. This conversational interaction truly transforms how we explore and prepare data.
Fantastic. With the data ready and understood, the next logical step is building and training our predictive model. This is where XGBoost really comes into play, isn't it?
Yes, stepping into the core of our machine learning pipeline, we encounter the XGBoost Manager class. This component is dedicated to handling the heavy lifting of model training, evaluation, and interpretation. It's designed to be the central hub for all our XGBoost operations, ensuring efficiency and seamless integration into our agentic workflow.
And for those who might not be deeply familiar, could you briefly remind us what makes XGBoost so special? Why is it a go-to for so many data scientists?
Certainly. XGBoost, which stands for Extreme Gradient Boosting, is a highly optimized implementation of the gradient boosting algorithm. It's renowned for its speed, performance, and its ability to handle complex datasets, including those with missing values and nonlinear relationships. It's a powerhouse for achieving high accuracy, especially with structured or tabular data.
So, the XGBoost Manager encapsulates the model's lifecycle. Let's talk about the train_model method. What happens there?
In train_model, we initialize an XGB.XGB classifier. We can customize training with parameters like max_depth, learning_rate, and n_estimators, or use sensible defaults if none are provided. The agent can either use standard settings or, with more advanced prompting, adjust these hyperparameters for fine-tuning. The method then fits the model to the training data, returning a confirmation like model trained successfully with 100 estimators.
Once trained, we need to know how well it performs. That's where evaluate_model comes in. What metrics are we looking at?
The evaluate_model method uses the unseen test data to generate predictions and calculates key performance metrics. We look at accuracy, of course, but also precision, recall, and the F1 score, specifically focusing on the positive class. These give a more nuanced understanding than accuracy alone, especially with imbalanced datasets. The results are packaged into a JSON object for the agent.
So, asking evaluate the trained model triggers this tool, and the agent presents the metrics in an easily digestible format. That makes assessing performance as simple as asking a question.
Exactly. But understanding why a model makes certain predictions is crucial for trust and interpretability. That's where get_feature_importance comes in. This method calculates which input features were most influential in the model's decision-making process and returns the top 10 most significant features with their scores.
And this feature importance analysis is integrated as the feature importance tool? So users can quickly query the model's key drivers?
Precisely. A user can ask, "What are the most important features for this prediction task?" The agent calls this tool, and you instantly get a list highlighting the features that matter most. This bridges the gap between black box models and interpretable AI.
Training and evaluating are vital, but truly understanding a model often involves visualization. How does the visualize_results method help us see the patterns?
Raw numbers and text outputs often aren't enough. We need to see the patterns. The visualize_results method in XGBoost Manager generates a comprehensive suite of visualizations offering a rich, graphical overview of the model's behavior and performance, making complex concepts much more intuitive.
What kind of visualizations are we talking about? I'm guessing a confusion matrix is high on the list for classification performance.
Absolutely. The confusion matrix visualizes true positives, true negatives, false positives, and false negatives. It clearly shows where the model is succeeding and, more importantly, where it's struggling, like misclassifying positive cases. It's essential for spotting those misclassification patterns.
And we also visualize feature importance, right? A bar chart seems like a much quicker way to compare the relative impact of features than just a list.
Exactly. The visualize_results method generates a horizontal bar chart of the top 10 features. This visual comparison helps us quickly grasp the relative impact of each feature. Is one dominant, or are several contributing equally? It's a glanceable way to understand the model's drivers.
What else is included in these visualizations? How do we assess the model's ability to distinguish between classes?
We visualize the true versus predicted distribution by plotting histograms of the actual target values and the model's predicted values side by side. A good separation indicates the model is distinguishing classes well, while overlap suggests difficulty. It's a simple yet effective gauge of discriminative power.
And what about the learning curve? I imagine that shows how performance changes with more data.
Yes, we include a simulated learning curve. This plots a performance metric, like accuracy, against the size of the training dataset. Ideally, performance improves or stabilizes as more data is provided. While simulated here, it illustrates the concept: more representative data generally leads to more robust models.
These visualizations collectively transform abstract metrics into tangible insights. They make the model's behavior accessible, allowing users to understand strengths and weaknesses without being deep ML experts. This visual feedback is crucial for iteration and building trust.
And now, we've built the components: data management, modeling, evaluation, and visualization. The critical question is, how do LangChain agents tie it all together?
This is where the magic truly happens, right? Orchestrating all these pieces under the control of a LangChain agent, allowing us to manage the entire ML workflow through natural language.
Exactly. At its core, a LangChain agent acts as an intelligent orchestrator. It takes a user's request, understands the intent, and decides which tools to use and in what order. Our agent is equipped with specialized tool objects, each performing a specific task. We have generate data, data summary, evaluate model, and more, each clearly described for the agent.
So, the create_ML_agent function bundles these tools together, taking the instantiated data_manager and XGB_manager objects, wrapping their methods into tool objects, and returning that list as the agent's toolkit.
Precisely. And the run_tutorial function demonstrates this. It orchestrates a sequence: first, generate data, then data summary, followed by train model, evaluate model, and feature importance. Finally, it triggers the visualization capabilities. The agent intelligently sequences these actions based on the workflow.
Imagine a user interacting with this. They might say, "Agent, please generate data, train a model, and show me the evaluation results and top features." The agent parses this, identifies the needs, and executes the corresponding tools in the correct sequence. It knows training requires data, and evaluation requires a trained model.
This agentic workflow transforms complex, multi-step ML processes into an interactive experience. Users guide the workflow through natural language, get immediate feedback, and gain insights through structured data and visualizations. This approach inherently enhances both interactivity and explainability.
By integrating these powerful tools, you've created a truly intelligent and automated ML pipeline. What are the key takeaways from this, and what does it mean for the future?
The key takeaways are significant. First, LangChain is a flexible framework for wrapping existing ML operations. Second, XGBoost remains a powerful algorithm. The combination is potent: XGBoost is the engine, LangChain is the control system. This agent-based approach demonstrates a new paradigm for automating the ML lifecycle.
Automating the ML lifecycle through natural language prompts significantly simplifies the process, making it more accessible. The ease of integrating data management, ML modeling, and visualization underscores its potential for enhancing existing ML infrastructure, not replacing it.
The benefits are manifold: democratization of ML by lowering the entry barrier, boosted productivity through automation, and enhanced interpretability. Imagine business analysts requesting reports or insights without writing code, or researchers interactively exploring datasets through dialogue. The possibilities are vast.
And this is precisely why this approach is so compelling. It's not just about building a pipeline, it's about building an intelligent pipeline. We've infused the dynamic, responsive nature of conversational AI into the structured steps of traditional machine learning. This isn't science fiction, it's practical application.
Think about the implications for learning and education. For someone new to ML, the concepts can be overwhelming. With an agent like this, a student can learn by asking, "Show me the data summary, train a model with more trees, why is the precision low?" Each question becomes a learning opportunity.
Let's expand on visualization. Beyond the confusion matrix and feature importance, we could extend visualize_results to include ROC curves or precision recall curves. These give a clearer picture of performance, especially with imbalanced datasets.
The beauty of exposing these as agent tools is contextual requests. If evaluate model reports a low F1 score, the user can ask, "Show me the confusion matrix and the precision recall curve." The agent understands the context and calls the appropriate visualization functions. It's a fluid, iterative debugging process.
And considering the data manager's role, it could be extended for real-world scenarios, loading data from databases or APIs. The agent could then be prompted with, "Load customer data from our SQL database, then split it 80/20ths." This requires the agent to interpret parameters from natural language.
Yes, if a user says, "Predict customer churn using customer_data.csv, split 80/20ths, the agent understands the intent, data source, and splitting requirement. It then executes load_data and split_data tools sequentially. This is a significant leap from generating random data. It's about interacting with real-world data sources and applying specific transformations.
Let's dive deeper into the XGBoost Manager for advanced interaction. What about hyperparameter tuning? Can the agent optimize the model based on specific goals, like better recall?
Absolutely. A user could say, "Optimize the XGBoost model for better recall on the positive class." The agent could then invoke a hyperparameter tuning tool, perhaps using libraries like Optuna, to systematically search for the best parameters. It would then report findings like, "Best parameters found, max_depth equals 5, learning_rate equals 0.05. Recall is now 0.85.
That's a game changer for efficiency, delegating tedious optimization to the agent. And what about explainability beyond feature importance? Can we integrate tools for generating SHAP values?
Definitely. SHAP values provide feature importance for each individual prediction. An agent could respond to explain why the model predicted churn for customer ID 12345. It calls a get_SHAP_values tool, explaining contributions like high number of support tickets contributed plus 0.3 to churn probability.
This level of granular, prediction-specific explanation is invaluable for building trust. The create_ML_agent function is the nexus. What other tools could we envision adding to the pipeline?
We could add tools for data pre-processing like scaling or encoding, a model selection tool to choose between algorithms, or even a deployment tool to interface with platforms. Each new tool adds functionality the agent can leverage. Effective tool descriptions are key for the LLM to understand.
And the run_tutorial function can evolve to showcase more complex conversational flows. Instead of a linear sequence, we could simulate a more interactive dialogue, allowing users to explore data and models dynamically.
This integration of LangChain Agents with XGBoost represents a philosophical shift, moving from writing code to perform tasks to describing tasks and having an intelligent system execute them. This has profound implications for accessibility, productivity, and innovation.
We're building a layer of conversational intelligence on top of ML infrastructure. This layer understands intent, breaks down requests, and orchestrates tools. It augments expert capabilities, freeing them for higher-level problem-solving.
Consider team collaboration. A shared agent interface allows a business stakeholder to ask for reports, a junior data scientist for tuning help, and a senior engineer for prototyping. The agent acts as a common ground, facilitating communication across skill levels.
The prompt engineering aspect is crucial too. The agent's response quality depends on the LLM understanding the prompt and the tools being well described. It's a symbiotic relationship between human instruction and AI execution.
Looking ahead, challenges include scaling, reliability, and security, especially with sensitive data. However, the architecture agent as orchestrator, tools as encapsulated functions, LLMs as the reasoning engine, provides a robust foundation.
This journey from a manual ML pipeline to a conversational one is about more than efficiency, it's about making ML more human. It brings us closer to a future where complex computational tasks are accessible through natural language, fostering understanding and accelerating innovation.
Ultimately, this integration of conversational AI with powerful ML tools represents a significant step towards a future where machine learning is more human-centric, intelligent, and accessible. It's about making sophisticated technology work for us intuitively, unlocking new possibilities for data science and beyond. The maestro has arrived, and the orchestra is ready to play.